Welcome to qnawire.
An exponential function is a function that can be written in the form of, so some function f of x is equal to b to the x for some constant b. And notice that the variable here, right, the independent variable x is in the exponent. So we have some constant b raised to some power, but the power, right, is the variable. So b to the x, where the variable is in the exponent. But your constant b must be strictly positive, must be greater than 0. Because if b was less than 0, if b was negative, then your function would not be defined for certain values of x. Let's say if b was -2, and let's say your exponent is you had -2 to the maybe to the 1/2, well then that's the square root of -2, which is not defined in the real numbers. So b, your constant b, must be strictly greater than 0, so it must be positive, but it cannot be equal to 1, because if b was 1, well then 1 to any power is just 1. So b can't be 1 and b must be positive. Okay, so we're given some functions. So for a, we are given f of x is equal to x squared. Okay, so is this an exponential function? Well, is it some constant b to the x? Well, I mean, no, right? Here we have x is your base. X is the variable, right? The independent variable is not in the exponent. This is x squared, x to the second power. So you have a fixed exponent. So this would be a power function, not an exponential function. So this would be no, this is not exponential because, well, your variable x is not in the exponent. Okay. For b, we've got g of x. G of x is equal to 4x. Okay. Well, again, is this an exponential function? Well, do I have my x, my variable, in the exponent? No, right? Right here, you don't see any exponent, but you could write this as 4x to the 1 if you want. And again, this is a power function. This is a linear function. But again, is your variable in the exponent? No. So this, again, is no. This is not an exponential function. All right. How about the next one? Is the next one exponential? So the next one, we've got h of x. Again, the letter here, f of x, g of x, h of x, is just naming your function. Functions can go by lots of different names. Many times you'll use f for function, but g of x is another, typical, probably because it comes after f. But really, I mean, you could have any possible, and so all these examples, we have different letters that represent your function. But you can always just think of it as f of x. So again, it's in this form. It doesn't have to be f of x. It can be any letter can represent your function. Okay. But again, here we have h of x is equal to 8 to the x. H of x is equal to 8 to the x. Okay, so is this exponential? Can this be represented in this form? You have some function, h of x is equal to, is it some constant b to the x? Oh yes, b here is 8, and is 8 is greater than 0, and 8 is not equal to 1. So it is in this form. It's some constant to a power where your variable is in the exponent. So yes, 8 to the x is an exponential function. All right. Next one. Put it down here. Oops. For d, what do we have? We have a function s of x. So s of x is equal to 1 over x. Now is this exponential? Well, if you think of it, can I write this as with an exponent 1 over x? I mean, 1 over x, I could rewrite that as, right, 1 over x is the same thing as what? That's the same thing as x to the negative 1 power, right? A negative exponent just means 1 over x to the power this is, so it's 1 over x to the 1, which is 1 over x. So 1 over x, sitting as x to the minus 1, was that exponential? Well, again, no, right? Because my exponent is negative 1. My exponent is fixed. My variable is my base. So again, this is a power function, not an exponential function, because my variable, in this case x, is again not in the exponent. So no, 1 over x is not exponential. It is a power function. All right. What do we have for e? Let's see. E, we have a function that's called t of x. T of x is equal to 0.92. So 0.92, and that is raised to the x plus 1. Okay, so is this exponential? Well, is it some constant raised to a power? Well, it is, right? Because I have a constant. A 0.92 is a constant. Now in this case, it's not a whole number. Is that okay? Well, yeah, b, the only restrictions on b is that it has to be positive. 0.92 is positive, and it can't be equal to 1. 0.92, not equal to 1. So yes, my constant b is fine. What about my exponent? I have x plus 1. So that might look different to you than just, it's not just to the x, but you can have an expression here. I mean, really, x plus 1, I mean, x is a variable. X plus 1 is a variable too, because it depends on what x is. So just because this is an expression in my exponent, the fact that my variable is still in the exponent makes this an exponential function. So yes, you can have an expression in your exponent as long as the variable, whatever your independent variable is in your exponent. That's going to be an exponential function. So is this, again, some constant b raised to a power where the variable is in that power? Yes. So yes, this is an exponential function. All right. What do we have next? So for part F, we have a function r of x. So r of x is equal to x to the third power. So x cubed. Is this exponential? Well, is it, again, some b to the x where b is a constant? Well, no. In this case, my base is the variable, and my exponent is fixed. So again, this is a power function, not an exponential. My variable is not in the exponent. So x cubed, that is a power function. No, that is not exponential. And we've got, I think, 2 more, right? So we got part G. We got a function that's called p of x. So p of x is equal to the square root of x. Now this is kind of, I mean, in somewhat it's similar to this 1 over x, where it's not, again, you don't have an exponent right away in what it's given to you, the square root of x. So, but can I rewrite this? Well, yes, if you remember that the square root of any number is that number to the 1/2 power. So the square root of x is x to the 1/2. And then is this in this form where I have some constant raised to a power where the variable is in the power? No, right? The variable, again, is in the base and the power is fixed. That's a power function, not an exponential, so that it would be no. And then we have our last one. We have h, which is a function, I believe it's called d of x, and that is equal to the absolute value of x. So is that an exponential function? Well, that's a little different, right? Here I can't really make this as, try and make this with an exponent. Well, it's the absolute value function, but is there any way to put this in a form where I have some constant raised to a power where the variable is in the power? No, right? The absolute value of x, that's it. That takes any number and basically makes it positive, but there's no way to make this into an exponential where the variable is in the exponent. So no, that is not exponential. So we were asked which of these are exponential, and we see the ones we marked yes. This one, right? C, h of x, a to the x is exponential, and e, right? Even though we have in the exponent we have a expression x plus 1, but we do have a constant raised to a power where the variable is in that power. So those would be the exponential functions. All right, take care.